And welcome everybody to the Daily Space Weather. Today we'll be talking about Sunspot 2799, how it's grown, a state of geomagnetic unrest, the North Heliospheric Current Sheet, and ridiculous amounts of snow, especially in California. I'm your host, Dan, aka smAsho. Thanks for tuning in. First thing we're looking at is the northern hemisphere of the local yellow dwarf. Sunspot 2799 has grown. It's the one under my pointer. And you can see the fields growing a little bit there. This active region on the left, not a sunspot as far as we know. Sunspot 2797 has been pretty steady over the past 24. Here it is in three wavelengths, 335 angstroms, 193 angstroms, and 94 angstroms. And you are currently being buffeted by a coronal hole wind stream, folks. That's how the geomagnetic unrest has occurred. It's a result of high-speed protons striking the magnetosphere. The 10.7 centimeter radio flux, a measurement of the outer coronal radio output, is at 78 solar flux units. Having been flatlined for a few days here, there's the one-year chart to put that in context. And there you can see the proportionality between sunspot number progression and the radio flux. And back in the 1940s, we could use the radio flux to guess what the sunspot number was when it was too cloudy to see the sun on ground-based systems. Let's take a quick look at the view from Lagrange point 1 from the Soho Lascaux C2 to show you no coronal mass ejections, at least as far as the data that we can see. There's a little bit of missing data from stereo A, otherwise we'd show you. And next we're going to show you a chart of the solar system. First I want to check the life of the stream as we are streaming live. It's twitch.tv/smAsho. There's what's going on currently in the solar system. Please leave us a comment if you're viewing from a different solar system, plane of existence, timeline, spaceship, galaxy, universe, etc. And there's where we expect things to be in a week. Next, I've brought up in-the-sky.org. It's what I use for my star charts. And if you're up before dawn, you may see Mars and the Moon quite close to each other on the ecliptic, which is that yellow line that we've drawn in. And we've got some fantastic helioviewer movies once again. First, we'll show you 304 angstroms. Check out the filament down in the southeast. And for you new viewers, this is the southeast down here. Check out that filament by my pointer. Yowzers. That is some serious filamentary behavior. That did not appear to eject, by the way. And our patrons would have heard about this yesterday as I was keeping an eye on it. And when I say an eye on it, well, the eye on, the pun is intentional. Here's a close-up of that area. And again, that filament appears to have not ejected. It looks like it rained back down into the chromosphere. Here's a close-up of Sunspot 2799, and we'll show you more close-ups of that before the end of the video, as well as a full disk view at 193 angstroms. Great view of those magnetic fields gaining in strength. So it is back to a beta-class sunspot now, and the likelihood of significant solar flares has actually gone up as a result of that. And again, we'll show you more close-ups of that in different wavelengths by the end of the video. Next, we're going to go over volcanoes, as I'm always interested in what is injecting all kinds of aerosols and volcanic ash into the atmosphere, much less complete covidiots injecting metallic particles intentionally into the stratosphere. We won't even get into it. Here's the real geoengineering that's going on your planet. It's volcanic eruptions. Mount Dacono, it's a flight level 050 over Mount Dacono. It's a 5,000-foot altitude ash plume. Popocatépetl exploding, 18,500-foot ash plume there. Fuego exploding, 15,000-foot ash plume there. Sangay down in Ecuador, as well as Revenador in the same nation, both exploding, producing a 20,000-foot ash plume at Sangay and a 15,000-foot ash plume at Revenador. And Sabancaya is producing sporadic emissions as well. Please don't attempt a back handspring over the caldera. We see a minor uptick in earthquakes here over the past 24. We'll go over the list. Yesterday at 10 o'clock Universal Time, we saw a deep quake at Fiji. It was a 4.8 magnitude at just under 100 kilometers depth. One of the largest of the past 24 must have been this 5.5 in the South Shetland Islands. And we've seen a couple quakes there right in that same region, right at the northernmost tip of Antarctica. Here's a deep quake at New Zealand, a 4.2 at nearly 200 kilometers. Let's just check the location of that one real quick. And it's actually between the North and South Island. There's a location of that. And we're just going to scroll up the list here. No quakes over a 6 magnitude have occurred in the past 24 hours. Deep quake in Tajikistan at a 5.2 magnitude. A 5.2 at New Zealand as well. And that one looks like it might be on the North Island. Let's take a look at that one as well real quick, as there's been sort of an uptick in volcanic activity. And that one is located right on the shores of Lake Tarawera. Decent size quake there in New Zealand, a 5.2 magnitude. Here's a deep quake at the Kuril Islands south of Kamchatka. Here's a super shallow quake at Hawaii. It's 600 meters above sea level. And that one looking like it's just below the caldera of Mauna Loa. There you can see the location of that quake. 600 meters above sea level, about 1,800 feet of altitude. So a shallow quake there. Also a deep quake at Bolivia, over 260 kilometers depth, where that 4.4 magnitude quake struck Bolivia. Here's a 5.4 at the U.S. Virgin Islands, one of the largest Caribbean quakes we've reported on for quite a long time. Small deep quake strikes Alaska, a 5.2 strikes Japan, a 5.2 strikes Papua New Guinea. That one is at depth just over 100 kilometers. And let's move on to talk about the stream and how we are streaming live. Again, it's twitch.tv/smAsho. Perhaps check out the mobile app for that. And we've brought up the 3-day solar wind chart here. And you can see the phi angle has recently shifted around a bit. And you can see this drop off in the solar wind density. Followed by an uptick in the solar wind speed. So there you can see the solar wind speed now at over 500 kilometers per second. The solar wind density actually came up a little bit there. Could be some sort of like a double pulse, sort of a coronal hole wind stream there. And you can see the temperature may still be climbing here. So current solar wind over 500 kilometers a second. Current solar wind density just under 10 protons per cubic centimeter. Probably something like 8 or 9 protons per cubic centimeter. And there you can see the KP index, a measurement of global geomagnetism at 4, a state of geomagnetic unrest. Now we're going to show you magnetosphere movies in 2 different formats here. We're going to show you the density and the pressure. And you can see low density there in lighter colors, high density in dark blue. Keep in mind this only shows you 0 to 4 protons per cubic centimeter, as per the scale at the top. And there you see those recent striations in the solar wind density. Here's the solar wind in terms of pressure, or really it's the geospace magnetosphere in terms of magnetohydrodynamic pressure measured in nanopascals. And that's 4 more hours of data. Next, we'll show you ground magnetic perturbations. Here you're going to see the pressure come up. Right at the end, there you go. There's an increase in the pressure just in the past couple of hours while I did show prep. Next, we'll look at ground magnetic perturbations, and here's the polar view. We can expect to see some auroras sparked up from this, and we'll show you that on the next slide. I failed to bring it up, but I'll bring it up anyway. Some major auroras there over northeastern Canada. A large portion of Canada expected to see auroras from that. Here is the global view. And that's the effect of that high-speed coronal hole wind stream from that South Pole-oriented coronal hole. We'll show you it later in the video in a couple different forms. But that's 4 hours of data of ground magnetic perturbations, and we see significant ones. And before we do a cosmology segment, we'll look at the auroras real quick. And here's a 30-minute Aurora forecast. And if you get photographs of auroras, or if you're in an area where auroras are likely to be seen, set up a camera on time-lapse. There may be auroras visible that you cannot see with the naked eye. It's a normal thing. It's a normal thing for cameras to pick up auroras when you can't see them yourself. So if you're in one of these likely spots, try just taking a photograph. There may be auroras there that are invisible to the naked eye. You're only able to see a small portion of the electromagnetic spectrum, folks. And the emission spectra of the aurora can be outside your visual abilities. You'll see this kick up at the end. The last couple hours here as that coronal hole wind stream strikes. So some significant auroras there for planet Earth. Now, yesterday's cosmology segment included some information about an odd X-ray source. We'll get to it. First, we're going to look at cosmic rays. Here is the situation at the Apatity neutron monitor. You can see it's actually a downtick over the past 30 days at Apatity. And here's Barentsburg, a similar downtick over the past 30 days there. Next, we'll go to Athens, Greece, and check out the neutron monitor at Athens. We actually just saw a significant spike here in cosmic rays just today at Athens. You can see that little spike there over the past 30. That's a 30-day chart of the Athens neutron monitor. Next, we'll go even farther south to Mexico City. And you can see a pretty flat graph there over the past 30 days. Mexico City's Cosmic Ray Observatory. And lastly, we'll look at Oulu and 2 Antarctican monitors going really far north and really far south. So there's Oulu, Finland. Downtick over the past 30 days at Oulu. Here's DOMC Antarctica. Flat over the past 30 days there. Here's DOMB Antarctica. A larger range, but still a flat graph over the past 30 days. And if you wanted to monitor cosmic rays yourself, just do a search for cosmic ray links to cosmic ray data, and you'll find this webpage. Now, yesterday we talked briefly about AT 2019 WAY, and what this is a low-mass X-ray binary, a candidate for a, quote, black hole, end quote. We'll just say it's a massive radio source, and we'll close that one out. If you want to read about it, just look up AT 2019 WAY, spelled W-E-Y, and you'll find out about that. Let's pick another random object between 1 and 1031, and today's quantum die throw yielded a result of 48. And what object might that be? Well, it's quasar B0119 plus 115. So I'm always interested in quasars. Quasars and blazars are super important in cosmology in that these objects feature poloidal fields that are aimed directly at you. So I think cosmology is a lot like a game of pickup sticks. And I think a lot of the sticks in the game of pickup sticks are indeed invisible. The reason these objects look so bright is because of the difference between toroidal fields and poloidal fields. We did a cosmology segment all about it. If you haven't checked out our playlists, head to youtube.com/smAsho/playlists, and you'll see it. And let's zoom in on this one on Aladdin Light. And there's a great view of that quasar, a very distant object, and you would be looking directly down the pole of it. So in other words, instead of looking at it as an edge-on, you would be looking directly down the polar field. So here it is in X-ray from the Chandra. Here's the XMM Newton vision. Oh, it's not showing up there. Does it show up on BAT? Nope. How about Fermi? And let's look at it on the 2MASS. And it's pretty dim in infrared light. Again, that quasar B0119 plus 115. And perhaps we'll put a follow-up on that tomorrow. But in any case, there it is on Simbad. And you may be seeing the jet that's facing away from you there. That may be what that red jet is. But this bright area is a poloidal field that you're looking directly toward. In other words, if you're looking at a galaxy, and the galaxy looks like this, it's likely to be a radio galaxy. If you're looking at a galaxy and it just looks like a very bright spot like this, it could be a quasar or blazar. Perspective is everything when it comes to cosmology, and this is a consistent X-ray source, as you can see, quite consistent over the past 15 years. Quasar B0119 plus 115. Item number 48 at the Neil Gorell's Hard X-ray Observatory. And that's today's cosmology segment. Let's talk about some more stuff, like fraud, and how you should be following me on Twitter as we expose all sorts of things, and we talk about stuff not space-related. Now, perhaps you would prefer that I don't talk about big tech and its censorship and fraud, since big tech's trying to break the internet. But since it affects our videos, Google, Facebook, Apple, Twitter, and Amazon cannot break the internet, but the internet can break these companies. Watch them self-destruct before your very eyes. Have you been using the term Google as a verb? Well, we would implore you to please stop, because it means to use the Google search engine to obtain biased information about someone or something on the World Wide Web. Google doesn't even refute this idea. It is a known thing. If you can pay Google money to appear higher on search results, that would be a biased search result. To use it in a sentence, I Googled it, and now I know less about it. So in any case, we've opened up a new store here on Redbubble, which is slightly less censored, and we've produced another product here. So we've got the Google definition shirt, but now we've also got this design. As 2020 voted for hell to be the dimension of the year, and you can see all kinds of great details on here. 1984, aka 2020. Dimension of the year, hell, as Harris and Biden hurl the U.S. into a ever-deepening and darkening abyss of dastardly, dim-witted Democrat douchebaggery. You can find the shirt. And by the way, congratulations on surviving a global pandemic so far. But you can find that at the smAsho merch shop. And you can link to that from smAshomash.com. So if you haven't gone to smAshomash.com, check that out. You can link to the forum there, as well as all of our social media. And if you post things on the forum, as long as they're legal, we will not censor you. We don't even censor things like comments. And there's the new link to smAsho merch. Look for more coming soon at Redbubble. And congratulations on surviving a global pandemic so far. Thanks to our new followers over on Twitch. It's twitch.tv/smAshomash. Don't forget to press like and subscribe if you enjoy the content on YouTube. The video can't continue until you do so. And look, now the place is on fire again. So Before we burn to a crisp, press like and subscribe so that we can afford a fire extinguisher. Have you pressed like and subscribe yet? Well, I guess I'll just continue on. Thanks to our new subscribers over at YouTube. In all seriousness, don't forget to press share and press the notification bell. Thanks to our new subscribers at BitChute. As things are improving around here, thanks to our patrons, a true source of funding for the content. Our patrons are well aware that they receive early warnings about all kinds of things. You can become a patron too at patreon.com/smAsho. Patreon.com/smAsho, the main source of funding for the content. Thanks again, patrons. And we update this credit crawl every month. Patrons are listed in order of lifetime contribution. Next, we're just showing you a diagram of the atmospheric layers, such as the troposphere, where all your weather occurs and where you live, up to the thermosphere. This is the ionosphere right here. And that's where the GOES 16 makes its measurements, and that's why we show the slide daily. Here's the X-ray flux, and we saw 2 minor B-class flares over the past 24. Nothing to write home about. Proton flux is flatlined. We haven't seen any coronal mass ejection strikes, so there's that. And the GOES magnetometer is looking pretty sawtoothed here. We're seeing spiky patterns, and for you new viewers, the M's and N's stand for noon and midnight local time for the GOES 16. In other words, midnight, it's on the other side of the planet, opposite the sun. In between the Earth and Lagrange point 2, actually. So here's what we're talking about with the current sheet. The Earth is now in the North Pole-oriented current sheet shown there in green. Keep in mind the data is 1 hour and 11 minutes old and can change with no warning. But that's the top view ecliptic plane field plot. A great view of the heliospheric environment in terms of earthly and solar magnetism. Here's a line of sight coronal hole plot, and the coronal hole wind stream that we're seeing right now is from this coronal hole right here, that South Pole oriented one at the end of my arrow. That's where all those solar protons came from, showing up at over 500 kilometers per second, which is pretty quick. Here's another line of sight field plot. It also shows you the B field in blue, just like the last slide. It also shows you the poloidal fields of the sun, which, by the way, looks very, very different if you viewed it from the polar regions. It would look brighter and more like a donut because you would be inside of a massive coronal hole wind stream from the poles. Lastly, we're going to show you the diagram of the coronal magnetism, the magnetism of the sun's corona, the atmosphere of the sun. It's a chaotic place. We show it daily, pretty much just for fun. Next, we'll move into some more earthly data. Here is the ionosphere map for the past day. Ionosphere looking pretty normal here, actually. Slightly excessively charged up in the southern hemisphere. It is summer down there. And we do see some anomalies actually here in the ionosphere. Not too extreme. Here's the latest image. That one coming in at 10 o'clock Universal Time. Next, the total electron content forecast. And I would forecast this to be lower. So here's my forecast. There you go. There's my forecast, lower than NOAA's forecast from all of those high-speed protons striking. So here's the 3-day chart, and you can see it's actually already cratered, just as those high-speed solar wind protons showed up. And if you're wondering what the solar wind is made out of, it's made of mostly hydrogen nuclei. Hydrogen nuclei, yes. So here's the total electron content forecast, staying with electrons here. And you can see some significant anomalies here. And we see more anomalies with low electron flux than with high electron flux, as there appears to be some sort of a relationship between how organized the Earth's Van Allen belt is, at least the inner Van Allen belt, which is pretty much what you're looking at here. This is showing you the electrons in between your handset and a GPS satellite. And those areas where it gets red and orange and so on, those would be areas of high GPS error. And we see some anomalies here over Antarctica and over the northern portion of North America as well. And that's a reason to keep your Wi-Fi accuracy turned on if you're using a GPS. As you could see readings like 1,000 miles off when you see electron flux anomalies over your location when you're using only a GPS and not using Wi-Fi accuracy. To put that in context, there's the 1-year chart. And before we continue on, let me just check the life of the stream. Excellent, excellent. So there's the 1-year chart to put the electron flux in content, and we've been at quite low levels here for a solid couple of weeks. Next, looking at the jet streams, here at nullschool.net, there are the jets of the eastern world, and they're pretty kinked in the southern hemisphere. A little bit more orderly in the northern hemisphere, but doubled up over a few spots, and sending some very cold air into the Himalayas and the Middle East. You can see that polar air moving almost due south. Next, looking at the western world's jet streams. And wait till you see the snow forecast for California. It's cray. 4 feet of snow forecasted. We'll get to it. And if you're looking at a forecast more than about 4 days long, you're probably looking at a bunch of nonsense. Anyway, there are the jet streams of the western world. Very incoherent there in the southern hemisphere. Look, it's all over the place. Incoherent jet streams over South America. We saw massive lightning here over Texas, Oklahoma, Missouri, Arkansas, and a little bit of Kansas. Check out the lightning on the GOES 16 lightning mapper. Yowzers. And we see some heavy storms in the south central part of the U.S. and some heavy lightning striking right now. So if you're watching live, hey, Fort Smith, hey, Muskogee, hey, Tulsa, there's thunder rolling in. Hey, Cherokee Nation. It's pretty thundery. Anyway, I like to use lightningmaps.org when I hear thunder. Hey, Springfield, get outside and look to your east. You may see some interesting stuff happening above those thunderheads. Things like blue sprites. By the way, somebody posted a hilarious article yesterday. They said, the clickbait title said, "We've discovered where blue sprites come from." So I clicked on the article, and guess where blue sprites come from, folks? Seriously, I want you to guess. Guess where blue sprites come from? They come from thunderstorms. Isn't that amazing? So check it out. We've got precipitation over a large portion of half of the country is covered in precipitation here. And again, wait till you see the snow forecast for California. It's crazy. We've got some ice storms falling there in Kansas, as well as heavy rains over the eastern portion of the state, southern Missouri, now moving into Tennessee, and that system looks like it's moving northeast. So here's the Euro forecast for snow through Thursday at 7 o'clock in the morning my time. So check it out. Let's see. Let's go to the Tahoe region. There you go. West of Tahoe, the forecast through Thursday morning at 7 o'clock Eastern time is 59 inches. Yeah. So we'll just zoom out a little bit here. That is a crazy snow forecast. And the GFS forecast isn't really refuting that. So we're going to roll this back. This is snow depth that you're looking at here. We're also expecting some nearly 2 feet of snow in some of the central U.S. We'll show you the GFS forecast as well. But there's where things are expected to be at 7 o'clock Eastern time. And those red areas indeed represent 64.2 inches of snow forecasted for that spot there. Yowzers. That is extreme. So here's the view from Tropical Tidbits. And that's through 7 o'clock Eastern Time or 12 o'clock Universal Time. And indeed, those regions there are showing like 4 feet of snow on the GFS forecast. And you can expect well over a foot of snow in parts of Kansas, Iowa, and indeed Nebraska. A little bit of New England too. And we're expecting some snow here in eastern Pennsylvania. For you new viewers, if you're wondering where we're located, SMASH staff and I are located right about there. Right about there in Lehigh Valley, Pennsylvania. Next, looking at a water vapor map for the Americas. Shout out to our international viewers. It's the NASA Goes Interactive Weather Satellite. And it's time for me to vanish. Let this thing continue to scroll. Great view of what's going on in the atmosphere, the water vapor satellite. It's part of the NASA Goes Interactive Weather Satellite suite. Here's what's going on in the cloud layer. Low clouds still over the Atlantic Ocean. Here's a water vapor for the lower 48, and you can see this atmospheric river starting to form here over the central part of the U.S., and it's being pushed by this dry mass of air. And you can see a rotating low here around the California-Nevada border. It's a counterclockwise rotation. And we'll actually zoom in on the Texas-Oklahoma border, the point of massive pressure gradient, just to show you what's going on there. And if you're flying a plane, if you're on a plane or flying one, across pressure gradients like that, expect some turbulence. Respect existence or expect resistance. Thanks again for tuning in, folks. We got bonus features. Don't forget to check out our playlists, youtube.com/smashomash/playlists. There's all kinds of stuff there besides the daily space weather. Thanks again to our subscribers, viewers, etc., our sponsors, supporters, and so on. Look for another product review coming soon. Thanks to SMASH staff. And again, don't forget to press like and subscribe, press the notification bell, press share, and thanks SMASH team for tuning in. Here come the bonus features. It's the intensity gram and the magnetogram. So here it is in high res. It's Sunspot 2797. And 2798 may have been resurrected here. We'll show you in a minute. There's Sunspot 2799. And there's that active region, which does not yet appear to be a sunspot. Let's check. I don't see any dark ombre. What say you? Here's 2799, which again has grown, and the likelihood of solar flares has now gone up. Don't be surprised to see a coronal mass ejection as well, folks. Here is Sunspot 2797. And I don't see sufficient darkness here to call that an umbra. And we've got some more bonus features here, our close-ups, as well as 193 angstroms full disk view of my favorite star. So yeah, here's the coronal hole that's sending that coronal hole wind stream our way. There's another one rotating in here, right there. So that's a good view there in 193 angstroms. And we'll go close up to close things out. Here's Sunspot 2799, the main area of activity on the local yellow dwarf right now. Nice view of that. Here it is in 304 angstroms, ionized helium. Ultraviolet light emission spectra. Here it is in 171 angstroms, crowd favorite, and my personal favorite wavelength. And I think we've got one more. It's 94 angstroms. Which, if you're new to the channel, you may not realize that 94 angstroms takes 10 images per minute instead of only 2. So the other one that takes that many images is 131, which is the aqua-colored. And you can see a little bit of flaring indeed came out of that sunspot. The 94 and 131 angstroms wavelengths are specifically designed to observe solar flares, coronal mass ejections, etc., like our channel. So in any case, we're out. Thanks for tuning in. Remember, stare at the sun, don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Visit our links, and may that solar wind be at your back.